You can like yell, make noises. Number 1, draw a parabola with the given focus and directrix. So the directrix is the line, and the focus is the point. And a parabola is the set of points equidistant from that line and that focus. So we know the vertex is halfway between that line and the point. So that's the vertex right there. And the parabola opens this way because the focus is trapped inside the parabola. The parabola never intersects the directrix. So I know that parabola has to open down. And you don't have to draw this, but if I have that distance from that point to the focus, that's apparently the same distance to that line. So clearly my picture is not to scale, but those two segments are congruent because the parabola is the set of points equidistant from the focus to the directrix. Number 2, derive an equation for a parabola whose focus is 0, 4, and directrix is the x-axis. It's essential that you draw a picture of this to figure out how to get this equation. So the directrix is the x-axis, and the focus is 0, 4. So if I sketch the parabola, I know its vertex is here at 0, 2, because that's halfway between the focus and the directrix. And then the parabola opens up, because it traps the focus inside. That's just a sketch, so let's pick this point here, x comma y. That distance is congruent to that distance. So that's 0, 4. That distance, the distance between those 2 points, x minus 0 squared plus y minus 4 squared, is equal to this distance. Well, that's the point, same x value, y is 0. So the square root of x minus x squared plus y minus 0 squared. We square both sides to get rid of the square roots, so we're left with x squared plus y minus 4 squared equals 0 plus y squared. Multiply that out, y minus 4 squared. Make sure you know how to multiply a binomial. Use the identity, make a table, but don't do the 9th grade freshman mistake. You get y squared minus 8y plus 16 equals y squared. I'm going to subtract y squared from both sides and get 8x squared minus 8y plus 16 equals 0. I want to get y by itself. I get x squared plus 16 equals 8y. So I'm going to divide by 8, divide everything by 8. It's in your best interest to divide each term by 8. And you end up with 1/8 x squared plus 2 equals y. So that's the equation of the parabola, whose focus is 0, 4, and directrix is the x-axis. Notice how the vertex, I didn't shift it horizontally, but I shifted it up 2, so that checks out. And 1/8, it opens, it's concave up, because that 1/8 is positive, and that makes sense. So that is the equation of that parabola that we sketched. 3, the directrix of a parabola 8y minus 24 equals x plus 2 squared has the equation y equals 1. Find the coordinates of the focus of the parabola. Well, I do not like the way this parabola looks. I'm going to get y by itself. So I'm going to add 24, get x plus 2 squared plus 24, and then I'm going to divide everyone by 8. And notice that this is in vertex form. Y equals 1/8 x plus 2 squared plus 3. I'm going to leave it in vertex form because that tells me information about it. I can quickly sketch this parabola. I know it has a vertex of -2, +3, and is concave up. It opens upwards. So that's -2, 3. The directrix is y equals 1. The directrix is that line right there. Find the coordinates of the focus. Well, I know the vertex is 2 units away from the directrix. So that vertex has to be 2 units away from the focus. So what point is that? And that is -2, 5. So the focus is the point -2, 5. And just by knowing how to draw this picture and knowing the transformations of the parent function x squared, we're able to quickly answer this question. Number 4, label a focus and directrix on the diagram below. So the directrix is a line, the directrix is the line, and the focus is a point. Then derive the equation of the parabola using the distance formula. So to derive the equation, I'm going to pick any point on the parabola. It can be anywhere, but I know that distance is congruent to that vertical distance there. Well, that is the point 1, 3. The focus is at 1, 3. And that's the point xy. I don't know what the coordinates of that point are. And the coordinates of that point are same x value, y equals 1, because the directrix is y equals 1. So this purple distance, that purple distance is the square root of x minus 1 squared plus y minus 3 squared. And that distance has to be equal to this black distance here of the square root of x minus x squared plus y minus 1 squared. The square roots actually don't matter. You might get to the point of not writing them. But you get x minus 1 squared plus y minus 3 squared equals 0 plus y minus 1 squared. I'm not going to touch the x minus 1 squared because that will keep it in vertex form, and I really don't want to have to go to standard form. I could, but I'd rather have it in vertex form, so I'm not going to touch the x minus 1 squared. I am, however, going to square out y minus 3 squared. Make a box on the side if you have to, but you get y squared minus 6y plus 9 equals, square that out, y squared minus 2y plus 1. I have a y squared on both sides, so I can subtract that out. I'm going to get the y's on the left-hand side, so plus 6y, and move that 1 over. So I get x minus 1 squared, those are gone, minus 8 plus 8 equals 4y. Divide both sides by 4, divide everyone by 4, and I end up with 1/4 x minus 1 squared plus 2 equals y. Check. Does this equation of the parabola match up with the picture? I shifted right 1 up 2. Right 1 up 2. That's the vertex right there. The vertex is 1, 2. That's what our equation shows. Is it a 1/4? I scaled it by 1/4, so it should be wider and be concave up. And that's what it looks like. So this is the equation of the parabola. 5. Find the equation of the set of points equidistant from the point 4, 3. Let's sketch that. 4, 3. Equidistant from 4, 3, and y equals 5. So there's my directrix, y equals 5. So if that's my focus, I know my vertex is right there, and this parabola opens down, because that parabola needs to protect the focus from the directrix. The parabola doesn't cross the directrix, it goes away from it. So pick any point. The focus is 4, 3. That's the point xy. And that distance, well, same x value as a y value of 5, is the same as that distance. Did a pretty good job there. Okay, so now let's use the distance formula. I'm not going to write the square root because I know I'm not going to need it. X minus 4 squared plus y minus 3 squared equals x minus x squared is 0, but I'll write it. And then plus y minus 5 squared. That's 0, so that doesn't matter. I'm not going to square that out because otherwise I'd have to complete the square to get it into vertex form, and I'd prefer not to complete the square. Plus, expand that out, y squared minus 6y plus 9 equals y squared minus 10y plus 25. I have a y squared on both sides. I'm going to get my y's on the other side. Move over my constant to the left-hand side, and I get x minus 4 squared. 9 minus 25 is 16, negative 16. Equals negative 4y. Finally, we get y by itself, divide by -4. Notice how I'm dividing everyone by -4. So I have -1/4 x minus 4 squared plus 4 equals y. Apparently, that is the equation of this parabola. Let's check. I have a negative leading coefficient, so the parabola is concave down. That checks out. I shift right 4, up 4. The vertex is 4, 4, because it needs to be 1 away from both of the, it's 1 unit away from the directrix and 1 unit away from the focus, so that checks out good. And that's it. So the set of points equidistant from a point in a line is the parabola. A parabola is, by definition, the set of points equidistant from its focus and a directrix.